All right, in this video, we're going to talk about congruence and transformations. So in the last few lessons, we've talked about transformations, we've talked about rotations, reflections, and translations. And we're going to talk about congruency now. And congruency is when two shapes are identical. They're the same size and the same shape. So we can prove if two shapes are congruent if the second one can be obtained from the first by a series of rotations, reflections, or translations. So if we can, what they call map one shape onto the other one in an identical way, then we would say that the two shapes are congruent. It's just a fancy geometry way of saying that they're the same shape and same size. So if we can map one onto the other using our transformations, we would say that they are congruent. So if you look at the example here, we're going to determine if these two figures are congruent by using transformations. So I've got triangle ABC and triangle XYZ, and right now they're not mapped onto one another, but we're going to use our transformations to try to place one of the triangles on top of the other. So the first thing that they did was they reflected triangle ABC over a vertical line. So they did a flip, kind of a left-right flip, and then they called it A prime, B prime, and C prime. So you can see that the triangle got flipped over from here to here. So now it's oriented the same way as triangle XYZ, but now we need to finish it by sliding or translating triangle A prime, B prime, C prime onto XYZ. So when we do that, you'll see that this triangle will map onto triangle XYZ exactly. And so we say that those two triangles are congruent because we can map triangle ABC onto triangle XYZ using a series of transformations. Here we have a couple shapes, and we need to determine if they are congruent using transformations. So if we were going to try to map the red figure onto the green one, we would have to reflect it, first of all, because they're almost mirror images of each other. So that's the first thing we would try to do, is reflect it. And then they tried to do a translation, or tried to slide the red one up onto the green one. And you'll notice that they won't match. This part of the figure on the red one will not match up with that part of the green one. So we would say that these two shapes are not congruent because I cannot map one onto the other using a series of transformations. Here, let's determine if these two figures are congruent using transformations. So it looks like I would have to do a rotation. So if I tried to rotate this figure to try to get it to match the other one, and then I would have to do a translation or a slide, and I'm just not going to get these two shapes to match. So I cannot map the red one onto the green one. So I would say that these figures are not congruent. There's no transformation that can map one shape onto the other. And that's basically what congruency is. If we can map or prove that I can map one shape onto the other using the transformations we've talked about, then we would say that they are congruent. So just real quick in review, the three types of transformations we talked about are the translation. Here, length is the same and orientation is the same. None of that changes when you perform a translation. It's just a slide. You're just moving it from one location to the other. A reflection, lengths stay the same, but the orientation is reversed. This is a flip. So it's a mirror image of what it used to be, and you flip it over a line. And then the rotation. Length, again, is unchanged. Orientation is changed. It's pointing a different direction. So when you rotate something, you're changing its orientation.